This is Abhishek, and my topic, or in fact, the entire agenda of my talk is going to be slightly a detour about how everyone talked about policy, how everyone is using AI, right? My talk is slightly going to be more on voice AI space, which is a new UX everyone is building these days, right? So I work for a company called Smallest.ai. And no, no, it's my log. Sorry. So we build foundational model for voice. We build text to speech, speech to text, speech to speech, and we have agent builders like for example, if you have received customer automated calls, right? So, but we focus more on the research side of it rather than we're trying to build the world's fastest low latency models which can run on small hardwares as well and which can also sound more natural as humans, right? So this entire talk is going to be about the thinking on how do we actually measure or evaluate a voice, right? Whether it's a human voice or not. That is one. And then in terms of usually what happens is whenever you're also benchmarking any LLMs, right? For example, there are a bunch of benchmarks where you talk about um, the hallucination that it comes out with, or the number of recalls it does with the context, right? Similarly, in voice, right now there are few benchmarks, but which are in very flawed, right? And this talk is mostly going to be around that. So this is Abhishek. I work as a developer relations engineer at Smallest, and we're gonna cover. Also, I want you all to keep it very engaging as well. Gonna ask you a lot of questions around it. We're going to see what exactly voice is. I mean, by the definition, and what you folks think of it, um, and the human problem of how do we exactly judge the voices. Like when given in a room, if I put 10 people together and give a voice samples, you see the chaos going on. And what's broken today in terms of when you measure the voice AI metrics, and what is my proposal to you all whenever someone is building this, right? Um, okay, one question to everyone. What is voice to you all? Can anyone answer that? Yeah, sure. Yeah, right. So that's the half of the answer, but thank you so much for taking that. Essentially, when you say it's a voice, primarily it's a three component. One is you have to identify who is speaking, right? Where if I am talking, this is Abhishek talking. If Amitabh Bachchan is talking, you know that Amitabh Bachchan talking, or someone else. It could be gender voice as well, right? Second is how I am talking, the style of it, sarcastically, in a sadness, right? And third is the context. The context is also very important to understand what they are trying to communicate to us, right? So these are the three foundation layer where you define that, okay, this is the voice. Whatever I heard, this is what the voice is, right? So if you see, voice is not a single parameter where you can just say that, hey, that's a voice I heard, but it's more like a behavioral different characteristics over different things, right? So it's not a one metric, it's not one thing. Again, throughout the talk, I'm gonna probe you in thinking that you should not be thinking of valuation tied towards a single or two to three metrics, because voice is a behavioral thing, right? So you have to think from the point of view how you can identify or make voice sound like humans, which has a different parameters. So whenever I say a metric, always think that I'm talking about not sticking to one single number or one single benchmark, right? So yeah, so that's the definition of voice. Now, how many of you knew that there are so many components to voice? Anyone knows? Anyone would like to cover this for me? Would love that. Okay. So I'm sorry to bring you back to the sound engineering session, but the foundation of that, it's pretty self-explanatory. But yeah, like there are six components when you say uh, apart from the layers in terms of identifying the voice. And again, there are literally a lot of research paper where they are talking about how do you actually define the voice, right? And these are like very few common components that you can derive from, but there are researchers who have added more components to it. The tone, of course, the attitude that I'm talking with, or like how bossy I am, for example, or hey, I'm so sad today, right? So the tonality of the is one component of it. Second is the timbre, the texture that sounds like me. This is how Abhishek is talking, for example, or not. I'm not sounding like, let's say, Shah Rukh Khan. So that's timbre is basically a texture of your own voice. So when you clone your voice, like a lot of and when you evaluate that, like this component should basically sit on top of it. Whenever you, let's say, even generate a spectrogram out of it. The pitch, the loudness in terms of volume. And I think it's a typo there, it's a rate, it's not rate. Uh, the speed that you talk, the pauses you take, etc. And of course, the accent. And accent here is not just regional accent, but it's also about how you talk in your friend circle, for example. Like you suddenly switch the languages. Um and if I'm talking in English, my accent is different. But if all of a sudden I change it to Hindi, मेरा accent कुछ और हो जाएगा, ठीक है? So you see the difference, right? So these are the six major components, and also there are few things that I will run faster because we are already running slightly late on the timing. But would love, this is a massive topic, but I would love to talk to you all post this talk as well, because I think I will not do the justice of combining everything within 30 minutes. But I'll still try. And every time when we talk about voice, there are a lot of repeated stuff that you would see in last slide or before that we have spoken about. Now, when you talk about analyzing a voice, how do you do a voice analysis? There are three layers to it. And these three layers are very much tightly coupled, because even if you misinterpret one layer, the entire conversation on the communication would mean something else. So one is the prosody of it, which is the naturalness or the rhythm of my voice that you have, right? Or let's say when I sing a song. Second is the emotional dimensions, which we will talk about it, and it is very interesting. I'm sure you all gonna love how exactly the emotions are mapped. Um, there's a framework called valence, arousal, and dominance. You basically map your voices, your acoustics in different dimensions, and then you figure out whether you are sad or not. So it's not categorical. Uh, so that is the second layer where you measure the emotional dimension, and the third part is the detection of it, right? Um, this is what I was talking about, and this is the only framework which can help you identify how do you measure a voice, right? And then we have some more things also here going on. So valence, as I mentioned, is a value that defines a positivity and negativity in your voice. Let's say if you have a high valence, which means that you are joyous, you are happy, or you are in love, for example, when you are talking. So that signifies the valence is high. We have a chart also later on to make you understand what I'm talking about. Um, Arousal usually means the energy of your voice, like how sad you are, how angry you are, the entire energy during the conversation that you're doing. Now, valence and arousal are orthogonal, like they are independent. You can, when you're angry, you can still have the same energy, and when you are happy, you can still have the same energy. But that doesn't mean, but these two things are different, right? So, high valence doesn't always mean that you are, let's say, high on energy, for example. And combination of both, or the product of both, is what derives the dominance of you, how controlling your language or a voice is, right? A boss giving you a command versus an intern coming and saying sorry to you, right? This the same sentences could mean different meaning as well. For example, let's say I'm ordering a coffee, or for say same example, if if a voice, if there's a sentence that has been given to a customer care versus if a same sentence has been given to your mom to say, right? So it could mean two different things altogether. Um, you can take a screenshot of this. I'm not gonna talk about this much because it's already available on the research paper. Basically, this is a Plotchik's wheel of emotion, which maps the entire VAT framework that we talked with different data set, it, which has a ranking basically. Like there are 20 to 30,000 words which are mapped with respect to VAT framework and they have numbering to it. You can read this later, but this is what I was talking about initially, that when you think of VAT, think of this, putting this into a 2D dimension. And if you look at the graph, you see that the fear and the anger both have the high arousal, but also on the same level, joy and love. The feeling of that is also very high on the both ends, right? But when you combine it, the dominance, like the outcome that comes out when you're happy and sad, it's very different. When you sound, when you talk in anger or love. So these are the three again. This is what I love about this framework is that it is not categorical. It doesn't say that if your balance is high, which means that you're happy, or if your arousal is high, which means that you are sad or angry. But it's a combination of that, right? So it's basically a continuous mapping of emotions. I can be annoyed. I can be slightly annoyed. I can be angry. I can be like, okay, I'm a little bit disappointed or something like that. But how do you categorize that, right? You cannot categorize it. So you cannot just put it in the labels. So it's continuous. And most of the reason why I'm talking about all this is the current evaluation frameworks that we see in voice AI space is very much stick to one of these parameters. It doesn't cover the entire system, like how exactly a voice should be tested or evaluated. Okay, I think we all are aware of this. This is the same example. Like if I give you a two or a single audio file and I put 10 people in the room and ask them to rate, I am 110% sure that everyone is going to give the rating very differently. Because, for example, a sad voice or its pitch could be different. For you, it could be different, right? So level of tolerance, level of understanding, the regional differences. Of course, it's very subjective, uh, but that's the point. Right now, when you again, there is something called Moss score, right? Which is more like a numerical representation of uh, how a voice is, more robotic or flat, right? And usually, when the number is between 4.3 to, I mean, it's rated from 1 to 5. The higher, the better, basically, right? So Moss is basically calculated based on actually humans who have done the sampling, who listen to audio, and then rate the numbering. Uh, there are algorithms which have been automated. Mostly now everyone uses NNMOS, which is a neural network machine learning model that I've come up with. So again, human perception challenge is what I just wanted to talk about. It's very subjective in the nature. If I give you a one voice and to other 5 people or 10 people, they will come up with a different scoring to it, right? Um, also, okay, let me know how much time I have. So in the traditional system, this is how they evaluate the voice in general. And when I'm talking about it, it's mostly text to speech, where you give a text to a machine and it generates the voice out of it, right? I'm not talking about STT here, which has a different parameters altogether to test, but these are mostly in context of TTS. Yeah, so as I spoke about the main opinion score, which means that it's very I'll be giving audio to raters. They listen to the audio and then they'll rate from 1 to 5. So higher the score, more natural the voice is. But we have no idea on which criteria, on which basis of the VAT system, if they are even using that or not, right? So that's mean. In pairwise preference, what happens is you just take the multiple audios and then you compare it, which one is better than last one or which one is better than audio A, audio B, or audio C. But there is no rational behind it why this is better. So it's still better than most, but again, it doesn't give you the exact context of why this voice is good. And there are different data sets, parameters that you can go ahead and look, which are actually based on MOS. And on top of it, they have put more data sets and benchmarks to just come up with the intelligence on whatever the context to the giver, go into the audio as well. So what right now we are proposing is you have to build a system around it. Not you don't have to use single metric to evaluate a voice, right? One is how intelligent and correct the voice is. Now this is where your ASR, automatic speech recognition system, or text to speech systems also come into the picture, because when you're building a voice applications or agent, whatever you call it, it's not just one model which is working. So TTS job is to just generate the voice. But then usually when you put this in production, or let's say a classic example, if I have to automate the airline booking system, right? In that, what happens is a user text comes to speech to text model, which generates a transcript, right? That transcription goes to a LLM in the middle, and the LLM does all the reasoning, what needs to be done in the next step. And this output of LLM goes to the input to the text to speech now. Now again, the audio is generated, right? So usually when you use these models in the production systems, it's like a cascading of one's output to another's input. In that case, your word error rate matters a lot. Like whatever I am talking, if model is not able to detect it properly, then it defeats the whole purpose. I mean, the LLM can take wrong actions based on whatever the LLM has interpreted, right? So yeah, this is the voice eval stack I am going to propose in terms of how actually you should do the evaluation based on the intelligence and the correctness of the output. The prosody correctness is basically what we talked about. We take pauses, the rhythm. In fact, when you take an audio, you generate the entire spectrogram, right? So you currently that's also not in place, right? You do not actually map. Even if you take if you click, you go clone my voice, let's say right now, and what I'm speaking, it's audio. And if you generate the spectrogram of that, it will come different. It will not be same. So how do you measure the quality of voice again, right? Um, and then same speaker identification. Basically, I'm not going to go deep in this. If anyone is interested, please let's take this offline. It's the whole topic. It's so basically speaker embedding is nothing but I take a voice, right? And then I basically convert that into vectors. Now this is the same case with LLMs, but in this case, you generate a spectrogram, and basically the tokens that you're generating are a representation of spectrogram in terms of vectors rather than a normal number which can represent a text, right? So there is a difference altogether. And I think same goes for how expressive it should be, and artifact detection is basically like not the pauses, the naturalness of the voice when you talk or when I say and you acknowledge or the laugh, etc. This is how it looks like when you put all this into a system, like in the evaluation framework. So if you look at the previous one, I mean, okay, I think I should. So the part that it covers again, I think this is labeled completely wrongly. But what system A is basically what we were measuring previously with the original MOS-driven architecture or the different metrics. And here, when you do the system based on these stacks, I mean the components that we discussed, it covers the broader range of it. Okay, I think I'm not going to cover this. Again, this is more of an implementation side. Basically, instead of taking a scoring, you tag the voices basically every time you generate something. Yeah. This is, I think I explained to you how the traditional system looks like. And this is how you should be putting what we discussed today in terms of how you should be detecting the artifacts like pauses, etc. The prosody analysis, the rhythm of the voice, the VAT scoring, and the identification like the speaker embedding, etc. And then you can generate again the radar scorecard is just an option. You don't have to do it. It's more of a output that comes out of it. So you will not go and write a code for it basically. And this is the example of how it looks like. Again, we have internally done this, and but still, it's way better than what were the traditional evals. Okay, that was not my voice by the way, but yeah. So this is how a system basically looks like in terms of evaluating a voice, rather than just depending on the one metric of it. Yes, this is okay. I think yeah. I mean, I can also talk about this offline. This is the whole huge topic again. Again, thank you so much. I will let the next speaker go on. I am available here, or I can take it outside in the lobby itself. So thank you so much, everyone.